Good day, gentlemen. Today we are going to learn about process, threads, and CPU cores. I am making this video in order to address certain misconceptions that even senior software engineers have. Without further ado, let's jump right in. What is a process? When people say a process is running, it is not actually something that interacts with the CPU core. A process doesn't get executed at all. It just represents a resource allocation and a boundary. Processes are not something that can run on a CPU core. The one that actually runs on a CPU core is a thread. It can be misleading to say that a thread runs inside a process. Instead, it is better to say a thread belongs to a process and that process belongs to an application. The threads use the resources provided by the process. So basically, threads are the ones that run on a CPU core. An application cannot run without a process. A thread cannot exist without a process because it requires a host environment to function. Every application must have at least one thread, which is called the main thread. If a process is just an assignment of resources like memory allocation, then what exactly do the phrases run a process or spin up a process mean? They all just translate to allocate some RAM and system tools for this application. When you start an application, a process is created. The operating system will assign RAM and give it resources like virtual memory, descriptors for files, and network sockets. After that initialization, the operating system will spin up the main thread of the application. This is often the entry point of a program, such as the main function in C++ or Java. Once the main thread is up and running, the code inside the main thread will then explicitly make operating system calls to spin up other worker threads. All these threads will make use of the resources provided to them by that single process. One application usually represents a single process, unless it explicitly uses multiprocessing under the hood. Threads are the ones being executed on the CPU core. A single CPU core can only execute one thread at a time. Look into your own device. If your processor has 8 cores, it means that it can execute 8 threads in parallel. The operating system decides which threads will execute on which CPU core. Crucially, the threads of a single application need not run on a single CPU core. They can run on any CPU core. The OS is really smart. It will dynamically assign threads to those CPU cores which have the least load. Keep in mind that these threads can be spread out and executed on multiple cores simultaneously if the application wants. The main reason a process boundary is used is to provide security walls between threads of different applications. The thread of one app cannot and should not interact with the threads of another application. Processes act as a sandboxed environment. They reserve resources and the threads use those resources while getting executed in the CPU cores. They cannot access the resources of another process. So if threads can run on any CPU core, won't there be any cross-application thread corruption? No, because a process blocks them from touching other apps. A process isolates resources for the threads of an application. But be careful. While processes stop cross-app corruption, race conditions and deadlocks can still happen inside your own application if your own threads try to fight over the exact same shared memory at the exact same millisecond. You have to use tools like mutexes to prevent this. Ultimately, think of a thread like a parasite. The parasite uses the resources of the host to survive. The threads use the resources of the process to run the application. If the host dies, the parasite dies too. If a process dies, all of its threads die instantly. The parasite uses the resources of the host to survive. The threads use the resources of the process to run the application. Thank you for watching.